Hi, everybody. Welcome back to the self-check section 3.2 to 3.4 video. Let's go ahead and take a look at number two. So number two states the table relates the weights and heights of a group of individuals participating in an observation study. Here we have heights and weights, height relating to tall, medium, and short, and weight relating to obese, normal, and underweight. And we have specific numbers for each. So with these contingency tables, we always want to add up the totals so that we can use these to calculate our probabilities. So let's go ahead and add up our columns. So 18 plus 20 plus 12 is going to be 50. And in the second column, if we add up this total, it's going to be 104. Third column, if we add up our total, it should be 51. And if we add up our rows, it should be 60, 99, and 46. So when you check your total, this is going to be your entire total. You want to make sure you're getting the same number. So if I add up 60, 99, and 46, I should get 205. And I want to double check my rows now. If I add up 50, 104, and 51, I will also get 205. So make sure your rows and columns are adding up to the same total. So that takes care of question A. We found the total for each column and row. Let's go ahead and find the probabilities now. So part B says find the probability that a random chosen individual from this group is tall. So what I want to write here is just probability of tall. And the probability of tall, all the totals of tall are going to be 50. And I'm just going to divide that by our entire total. So we would have 50 over 205, and that comes out to 0.2439. Remember to round to 4 decimal places with probability. Okay, let's keep moving. So find the probability that a randomly chosen individual from the group is obese and tall. So what I want to write here is probability obese and tall. So I want to find the intersection of obese and tall. So we're going to the obese row. I'm going to the tall column. And where are my lines intersecting at? That's intersecting at 18. So we're going to have 18 over 205. And that ends up being 0.0878, 4 decimal places. Okay, moving on to part D. Find the probability that a randomly chosen individual from this group is tall, given that the individual is obese. So let's write that out as our probability. So tall, given obese. So since it's saying given obese, I'm going to live in the obese row. That's my new space. So I'm in the obese row. So my total is going to be out of 60 now. So let me write that out. So my denominator is going to be 60. And so since I'm living in that obese row, it's asking tall given obese. And where's that at? 18 again. So it's going to be 18 out of 60. Okay, so we calculate this probability. It comes out to a nice 2 decimal number, which is a 0.03. Okay, moving on to E. Find the probability that a randomly chosen individual from this group is obese, given that the individual is tall. So now we are in the opposite. So probability of obese given tall. Okay, so since it's saying given tall, I'm going to live in that tall column. That's my new space. So my denominator will be out of 50. And since we're talking about obese and I'm living in my tall column, it's going to be 18 again. So here we'll have 18 out of 50, which is going to be 0.34, I believe. Excuse me, 0.36. I thought that seemed a bit off. But okay, so that is E. Let's move on to part F. Find the probability a randomly chosen individual from this group is tall and underweight. So we have another and statement. So tall and underweight. So the intersection of tall and underweight. So here is tall, here is underweight. Where's that intersection at? Where our line's crossing? That's at 12. So it's going to be 12 out of 205. We're back to our regular total. Okay, so 12 divided by 205 is going to be 0.0585. Okay, now the last of single selections, find the probability that a randomly chosen individual from this group is tall or underweight. So probability of tall, and now it's or underweight. Okay, so since it's or, we're going to add up those probabilities. So probability of tall, we already calculated this, which is 50 over 205. So let me go ahead and write that down. We want to add it to the probability of underweight. And so underweight is 46 out of 205. And we want to subtract any overlap. And that overlap we found in the previous problem was 12 over 205. So minus 12 over 205. And if we calculate all this, we should end up with 84 over 205. A little hard to see, but 84 over 205. Okay, now let's move on to multiple events. So if two individuals are randomly chosen with replacement, that means we're putting them back, we're putting the first person back in after we select them. Find the probability that both individuals from this group are short. So short, that probability is 51 over 205. So if we select the first individual, so let me write this out, probability of short and shorts. Okay, so that first person is going to have a probability of 51 over 205. That's my chances of selecting someone short right away. And if I'm able to put that person back in, the total stays the same. So what I would do here, if I want to select that second person, I would have the same exact probability, and I would just make sure to multiply those two probabilities. And so that comes out to 0.0619. And now, same situation, but I'm going to have without replacement, meaning once I draw that first person, I'm not going to be able to put them back into the pile. So same thing, probability of short and short. My probability of selecting someone short right away is still 51 over 205, but I can't put that person back in. So I'm going to be losing one short person. So 50 over 204. Our total decreases as well. And so this becomes 0.0610. But okay, so that's it for question 2. Hopefully this helps. Thanks for watching the video. I will see you next time. Thank you. Bye.